Hello, everyone. Um, Today we have Prasadi Jayakodi here with us today to address the gathering about data engineering. So before further ado, I'll start with a Women in Data Science video before we start with the session.
Okay, I can't hear the voice actually. Magisha, can you hear the video? I also can't hear the video. It's not audible.
Women in Data Science Worldwide has been around since 2015. We started pretty small as just one conference on Stanford campus, and our aim then was to simply feature outstanding women doing outstanding work in data science. And then we grew. We grew into a global movement, connecting women and also men around the world.
WIDS has grown organically, responding to what the needs of the community are, what women data scientists need, and exploring new ways to interact. Stanford University is proud to have been the birthplace of WIDS and a decade of growth. With our unique strength in data science, computation, and AI, Stanford was the ideal incubator to support this force for advancing diversity in data science. WIDS has had a lasting impact on data science at Stanford, with a co-founder of WIDS as a founding member of Stanford Data Science. Including multiple perspectives is baked into the core identity of our programs.
It's critical, and we need women in these roles. Every individual brings their own perspective, and so we need to make sure the entire workforce is represented.
Because it really fosters that sort of community building you want when it comes to not just data science, but really any, I think, efforts to try and engage more girls and women.
So the fairness mission that we have is really try to enable that two people with equal talent should have an equal shot at opportunities.
I also just encourage people not to give up and keep arguing for what you believe in and what's important to you and what you think will make a difference.
WIDS is about the sense of urgency we should all feel to ensure that women earn that seat at the table based on their skills and talent across the world.
WIDS has inspired me to believe that more is always possible.
WIDS has inspired me to think big. WIDS has inspired me to learn more.
It brings together some of the leading scientists in the world.
The journey is just beginning. At WIDS, we're not just envisioning a more inclusive future in data science and AI, we're making it happen. From equipping students with critical skills to advancing career development, we're expanding access to education, mentorship, and empowering support for tangible impact. The next decade starts now, with action, with us. Join us in shaping the future. Volunteer, mentor, or donate today.
I would like to introduce Prasadi Jayakodi to our audience ahead for her session. Prasadi is a senior engineer at Sysco LABS, Sri Lanka, with a wealth of experience in data engineering and cloud technologies. She is AWS and Azure certified, demonstrating her expertise in cloud solutions, data pipelines, and enterprise integration. Prasadi's career journey includes a transformative shift from software engineering to data engineering. She's previously worked as a data engineer at Octave, a part of John Kear's group, and at Acuity Knowledge Partners and Novigi Private Limited. Prasadi holds a bachelor's degree in software engineering from University of California, and also we are excited to have Prasadi join us for this session where she will share about her insights and expertise in data engineering.
Hello everyone. Vagisha, can you hear me properly?
Yes, Miss Prasadi, I can hear you.
Okay. Can you guys see my screen?
Yes, sir.
Oh, okay. I'm sorry if you guys not hearing me properly because I'm not feeling much well and my voice is not much clear. So excuse me if there's like any inconvenience.
No, it's okay.
Thank you, Vagisha and Vimuktini, for giving me this chance. So yeah, so this is my first time that I'm addressing this audience, Women's in Data Science, and I'm really glad about that. So before moving to the presentation, I will give a brief introduction about myself. So yeah, I'm Prasadi Jayakodi, and currently I'm working as a senior engineer in data engineering section in Sysco LABS. So that's about me, and today's presentation is about you can wait, I will remove this. So it's about from raw data to real insight. Basically, it's about Chris DM journey. So, and actually, it's going to be a really short one. So yeah, then without further ado, let's dive into the presentation then. So basically, this Chris DM stand for cross industry standard procedure for data mining. So it's basically a methodology that we are using for data mining. So when it comes to the data mining, what do we mean by data mining means? So if we come to the real world example, we do dig sand piles to find gold nuggets. So that's kind of a mining procedure, right? So this data mining is finding meaningful insights or like patterns of the data. So that's what basically data mining means. So if you come to the real world example, so let's say now in a supermarket, or like let's say it's Gills or Cargills or Love or whatever. So those owners want to identify what are the highest selling products, or vice versa, they need to identify what are the lowest selling products, and also maybe they need to identify which customers are at risk of stopping shopping with them likewise. So this data mining is kind of like finding useful insights of the data. So that's what basically data mining is. So why we do data mining is simply because we need to find those insights and use it in a way that we can increase the revenue of our business. That's the ultimate goal actually. So this CRISP DM is kind of a methodology that we can use for data mining. So if it comes to a real world example, when you are making a pizza also, there can be several methods, right? Whether we can make the pizza in Neapolitan style or traditional style or in what it called Italian style. So as far as I know, when it comes to Neapolitan style, so there are some strict rules. So the pizza dough should be in a particular size, and everything should be handmade, and we should fire the pizza in the firework. So but when it comes to traditional or Italian style, then there is no kind of such strict rules. There are some basic rules only. So likewise, even for baking a pizza, there are several methodologies. So we can choose method that we need according to our requirement. So likewise, this CRISP DM also that kind of a methodology that we can use for data mining. And not only this CRISP DM is available, there are some other data mining methodology as well, like SEMA, KDD, likewise. So you can refer to those later. So anyhow, this CRISP is the method that we use mostly in the worldwide. That's the mostly used data mining methodology in the world currently. So yeah, that's the basic idea of CRISP DM. And when we go inside, basically, this contains actually 6 steps, starting with business understanding, then data understanding, then data preparation, then modeling, then evaluation and deployment or data presentation. Those are the 6 steps that we can find in the CRISP DM. So let's go one by one. So first step, when it comes to business understanding, not only the data mining task, whatever task that you are going to do, prior to start the task, we should know what you are going to do, what is our final goal, what should be the outcome. So that understanding should be there. So we need to specify business objectives clearly. So that's what this phase does, right? So for example, maybe Keel's owner or the Kyle's owner given us a task. Okay, I want to identify at-risk customers or the churn customers who are like going to lose us sooner or later. So I need to identify those customers. So, or maybe you can say I need to understand which products that have the most sale, so I can keep a buffer of those products, so I know that my customers won't be disappointed because that product is always available at the store. Likewise, so we need to understand what's the business problem and what we are going to solve. So that's what this business understanding means. And next step is data understanding. So in this phase, what it means is, now we know the problem, we have to have a clear idea and we have to have a clear understanding on what are the data points that we need to solve that problem, or what data do we have and what data do we need, right? For example, let's say we need to find the most buying products, then obviously we need to have post data or the point of sales data, which means purchases made at a store. So for another example, if we need to identify who are the churn customers or at-risk customers, so it's very clear that we need loyalty transaction data. So that is like most of the supermarkets issue you a loyalty card. So whenever you exit the counter, they will tap it, so they know where are you at, which outlets you have shopped, and what are the items you have bought, and what is the average expenditure, and which time you have shopped. Almost all the informations are getting through this loyalty cards, right? So now we need to understand, okay, these are the data points that need. So how our customer is going to give this data? Maybe they can provide those data using CSV files or Excel files, or maybe they put those data into a database like SQL Server or SQL or whatever database, and maybe they have grant access for that database, or else maybe they have created a API endpoint and give us that. Likewise, we need to understand how we are going to get that data. What is the data source? And then in this phase, we need to understand, okay, now we have the source, maybe it's an Excel file or database or whatever. Now, how we are going to extract that data? You guys may heard about the ETL part, right? Extract, transformation, and load. So the first step is extraction. So how we are going to extract data from the source? So for that, either you can use tool like Apache Airflow or Azure Data Factory, or when it comes to AWS Glue script. So you have to decide with which method that you're going to extract data, right? And also with the extract part, after extracting data, you need to decide where are you going to store the extracted data. So you have to understand, okay, whether I have structured data or unstructured data. If so, whether I can store it in Azure Blob Storage or a data lake or a Delta Lake, or maybe a SQL database or a data warehouse, where I am going to store the data. And also in this space, you have to think on how I'm going to process the data as well. Because, this is not about 100 or 1,000 records. How many transactions we do made in a day in a single supermarket, right? So it's like millions of billions of records. So to process that amount of large data, you need to have a data processing engine in Excel, like Spark. So you have to have a clear idea on how I'm going to process and what is the tools that I'm used to process this data as well, right? And then with the data indexing part, there's another important part, that is EDA part. So most of the data engineers are very familiar with this term EDA, which means exploratory data analysis. So this is the place where we identify these kind of things, whether all the columns are available, so whether this data is complete, so whether there are lots of null values or missing values, there are lots of duplicates, and you have to have a clear idea on how I'm going to handle null values, whether I'm going to drop null or fill null, or how we are going to handle that, and so whether there are outliers. So likewise, you have to have a spot check or a kind of analysis how the data, and you have to understand the data. Likewise, right? And in the feature engineering part, sometimes our data science this team may require lots of fields. So you have to have a clear idea on whether those fields are exit as it is, or you have to derived from the existing columns. Likewise, so you have to understand the data in this ways, right? Now if we go to the next step, that is data preparation. So as this image says, it's true actually, the 80% of data engineering time is spent in this space. When it comes to the ETL part, this is the transformation part. So this is the phase where we involve data cleaning and transformation, right? For example, transformation is something like this. I will use a very simple example. Let's say a customer, so the supermarket owner wants to identify what are the products which have higher sales. So just assume that from two sources, same product come in two different names, like Coke, Coca-Cola. So in our data pipeline, or we should identify this Coke and Coca-Cola is the same. They are referring to the same thing, and we should get it as a common. We should give it a common name and get it as the same thing. Likewise, or sometimes what else? Let's say now particular supermarket owner need to know what is the sales of August month. So when it comes to the record wise, you may got in the column wise, there will be values like 3rd of August, 4th of August, like 17th of August. But whenever the date is, finally the column value should be August, right? Likewise, those kind of transformation should be happen there, the transformation part. And also not only that, you have to drop. Now in the previous steps, you identify whether there are duplicates or not. So in these steps, you are responsible for dropping duplicates and also null handling. Previous steps, you identify null values. Now you have to decide, you have to handle the null values. So how we are going to handle whether you can drop nulls, or whether you can fill nulls, or whether you can give a common value for the null values. Likewise. And also another thing is data cleaning or the trimming. This is something like this. Now let's assume now most of the time, whenever the BU or the business unit giving us the data, so the data is coming as a string format. So most of the times this data is entering by mostly those are entering by people manually. So there may be high chance of having mistakes. So accidentally there might be lots of spaces between those strings. So using trimming, we are removing those unnecessary spaces, because then only those data will be accurate. Otherwise, our data scientist teams tend to produce invalid output, right? So likewise, trimming is there, and also column renaming. So whenever business unit is giving us data, so their name convention is maybe not readable. For a particular column, they have named that column like, let's say, A, B, C, D, E, F, G. But as a data engineers, we have the responsibility give it a clear naming convention. Like if it's product name, we can name it as product underscore name. Likewise, readable, meaningful names we should give. And also the schema enforcement. As I said, so most of these data come in as string formats. But the thing is, we can't proceed data as it is, because later this data is used for lots of queries and those kind of things. So what happened is, so when you are executing SQL queries and those kind of things, to execute those queries efficiently, it is always better to have the data types in proper format. For example, if it's like a date format, instead of having that date format in string format, date should be having in date format. Okay, I will. So what I mean is, so we have to do the column renaming part and also the schema enforcement part. So this schema enforcement means we have to define the data types correctly. So if it's an integer, so instead of keeping it as a string, we should convert into integer. If it's a decimal, instead of keeping it as a string, we have to convert into a decimal. Likewise, so then only in future for our data scientists or our BI engineers can generate their insights and execute their queries correctly when the data is in correct formats. And also, not only that, in this phase, we may have to perform some joining actions as well. For example, now, as I said you before, so there may be some feature engineering parts, which means now data scientist team may request some kind of columns that we need you guys to give us these columns. So, for example, we need instead of birth date, we need the age of a customer. So to derive those kind of, I'm using very simple example, right? So to derive those kind of active like values, we may need to join two data set together, 2 or 3 or whatever number we need to. Sometimes we may need to join. So there, most of the time we may have to perform left join or inner join, right join, or full outer join, or according to the requirement, we need to perform some join conditions as well in this data preparation step. So finally, our ultimate goal of this phase is provide clean, accurate data to our data scientist team. And another thing is, from this data preparation step, after cleaning and preparing the data, we will store it in a particular place where our data scientist teams or BI engineers team can access. So from here onwards, main part of the data engineering work is over, right? So from here onwards, it's mostly responsible for data scientist team. If we go to the next step, modeling part. So as I said before, this phase is mainly handled by the data science team. So what they do is they use machine learning or like rule-based models to generate insights. For example, so as I said, so what can you do? Let's say it's customer churn prediction. So they can decide with which model that they are going to proceed. For example, they can go with decision trees, so which will predict like high churn customers who hasn't shopped for last 60 plus days. Or another option is they can go with logistic regression, so they can predict churn probability based on the features like purchase frequency or average expenditure, etc. So if the existing models are not perform well, then they can build a custom models as well. So that's up to them. They have to decide the best model to move forward. So being data engineers, what our responsibility in this phase is, as I said, provide clean, up-to-date data, right? So that's data engineering responsibility there. And when this is the final steps, evaluation and deployment. So Now let's assume that our data scientist team has built a model which predict customer churn, and it predict churn or at-risk customers, and let's assume that they send a personalized discount or a offer via SMS or email, right? So personalized discount. So to ensure that particular model works efficiently and effectively and model is reliable, we can go through these two steps, which means evaluation and deployment. So through this evaluation phase, what we measure is basically we can check whether the model works correctly, the model perform as the way that we expected, and whether it's identify the at-risk customers correctly. So whether it's perform better than the random guessing or any manual procedure, or the discount or the personalized discount working fine, and whether that costs to return customer to the shopping. And so likewise we need to evaluate the model performance, whether it's working fine or not, or whether it's giving us the expected outcome. So if everything goes well, then it's time to deploy the model. So when it's deploying, so basically in most of the times we do a pilot run. So in this pilot run period, for a long time of period, we are monitoring the performance of this model. Likewise, if everything goes well, then we can just move into the production. That's how that phase ends. So here also, data engineering role is basically provide clean, up-to-date data. So there, one thing to note down is we have being data engineers, we have the responsibility to schedule pipelines correctly, right? So we have to identify the frequency of data generating and how we are going to grab the data grabbing frequency. Maybe business provide daily data, or maybe they are providing weekly data or monthly data. So how we are going to schedule the pipeline, whether it's once a day or once a month, once a week, or real time, we have to decide that. And also I can remember in one use case that I worked, so they said that you have to use this pre-validation script to check the accuracy of data. So before 6 p.m. or 6 a.m. I have to run that particular script and generate some output, and using that output I have to decide whether this data is accurate or not. So then only I am proceeding, and I will fetch those data and do the transformation, and then get those data to the data scientist team. If the pre-validation script is failing, that means data is not accurate. So that means I'm not extracting the data, and I'm notifying all the data scientists and all the team that data is not ready for today. Yeah, likewise. So we have to have a proper mechanism to ensure that we are providing up-to-date, accurate data. So yeah, we cover all the 6 steps when it comes to the final slide. So if we say why crisp DM, actually it's kind of like a clear roadmap. So it's kind of like actually a clear roadmap that we can use to not being lost in a data jungle, I would say. So it's kind of like a step-by-step approach, right? Kind of like, so if you feel like you didn't perform well in a previous steps, then what you can do is you can come into the previous step and correct it and make improvements and then go back, kind of like agile. So that flexibility is there. And also it's scalable. So with you can apply this same what it called same methodology even for a small project or a like large scale project as well, even to generate a small report or a complete AI project. So that scalability is there. And also another special thing is we can consider this as a best practice. So since the whole world know about this concept, so if you are using this, then that kind of like a best practice. So in software world also, you know, double OP concepts, right? So double OP is also kind of like a best practice that we can follow. So everyone is aware, so there is a practice like this. So if you follow it, everyone is know what are you going to do and what you have done. So likewise, so it's kind of like a best practice. So and another thing is, though there are lots of data mining technologies, so methodologies like SEMA, KDD, this CRISP one is the one that is widely used in the world. So yeah, that's about why we are using that. So when it comes to key takeaways, we know that we identify that. So this CRISP DM is kind of like a framework which makes raw data to actionable insights. And also we understood that data is valuable, but only when processed correctly. So and also we did identify that if there is no meaning of any model, even if you put lots of effort and lots of money on that, if it's not finally generating any business value, or if it's not generating revenue of the business, and if it's not fulfilling business requirement, then there is no use of that model. So this CRISP TM fill the gap between this raw data and real business insights. So that's what actually this whole process do. So hope to get something on that. So yeah, any final thoughts, Vagisha?
Prasadi, in terms of implementations, is there like the possibility to go ahead with like AI to automate this process and then, get going?
Sorry, come
Um,
again.
Is there like any possibility for AI to automate this process that you mentioned and get going, or is it like a manual process?
I think we may can involve AI. I haven't had experience with that actually, but I think we can include AI as well. Most of the times, what I have experience with the manual process actually.
Okay, thank you, Prasadi.
Also,
So do we have any other questions? If not, we can wrap up the session for today. Aruna, Agisha. Okay, thank you so much, Prasadi, for the preparation and presentation.
Okay, thank you guys. Thanks a lot.
Yeah, see you. Bye.
Bye.